Number 2, here we are with the last learning lesson of Unit 7. We have solving with properties of logs. We've got 3 main properties that we're going to look at today and one old one that we're going to review. Our first property is the log product property. If we have log base b of a times c, you can split that up with addition into 2 separate logs, log base b of a and log base b of c. And these all go in reverse. So if you have log base b of something plus log base b of something else, you can put them back together with multiplication and write it as one log. The quotient property. Okay, if multiplication gets split up with addition, division is going to get split up with subtraction. So if you have log base b of a divided by c, we can separate that into 2 separate logs, log base b of a minus log base b of c. Order matters with this one. Whatever number's on the bottom, that one comes after the minus sign. Or if you're putting these 2 back together, whatever's after the minus sign is the one that goes on the bottom of the fraction. And the power property. We kind of got a sneak peek at this one last time when we were talking about natural log. Okay? If we have log base b of m to a power p, you can bring that power down in front of the log as a multiplier. Or if you have a multiplier in front of your log, you can put it back on top as a power. And then our identity property, log base b of b equals 1. Think about our very first lesson with logs, and we were talking about changing them back to exponentials. The answer to a log problem is an exponent. 1 is the power of b that gives me b. b to the first power equals b, so log base b of b equals 1. Okay, we got 3 example problems. One mistake to change. This middle one should be a minus instead of a plus. Okay, let's have you try those on your own. Go ahead and push pause and see if you can see how those relate to the ones above it. Ready, set, go. Alright, let's check in and see how we're doing. Log base 2 of 3 times x. We can split that up into 2. Log base 2 of 3 plus log base 2 of x. Just like up here when we split them apart. The second one gets split apart with subtraction. 5 first and then the 8. And the power property, we're going to bring that power down in front of log as a multiplier. 5 times log base 2 of 6. Alright. Our first problem where we're solving for x, let's see how we're going to use these properties. When we're solving for x, a lot of these we're going to go in reverse with our properties. We're going to put them back together. Log base 6 of x plus log base 6 of x minus 9. Okay, we're going to put these back together. It's an addition problem. They're both the same log base, so we can do it. It's an addition problem, so we will put them back together with multiplication. Log base 6 of x times x minus 9. Okay? And as you get better at this and quicker at this, you won't need to write that step. You could probably do x times x and call it x squared, and x times minus 9 for minus 9x in the middle. Alright, but this is how I'm going to do it for the very first one. And that way you can see where everything's going. And then we distribute that x inside. X squared minus 9x. Okay, we've got everything put back together. And we have log base 6 of x squared minus 9x equals 2. Now we're going to use our original definition of the log. Okay, the answer to a log problem is a power. 2 is the power of base 6, so 2 is the exponent on top of 6 that equals that quantity. So we should have 6 to the second power equals x squared minus 9x. Okay, 6 squared is 36. Do you see where it's going? We're going to turn this into a factoring problem. Let's get everything on the same side. Let's subtract 36 over and let's look to factor. What multiplies to negative 36 and adds to negative 9? Negative 12 and a positive 3. X minus 12, x plus 3. And that makes our answers positive 12 and negative 3. Phew! Alright. In our lesson a couple days ago, when we solved with a log, we then had to plug these back in and make sure they were positive inside the logs and equal, because it was log equals log. Today it's not log equals log, or at least this problem isn't. So they don't have to be equal, because it's not log equals log. But they do still need to be positive on the inside. So if I plug that 12 in, positive, 12 minus 9 is 3, positive, that one's good. If I plug negative 3 in, negative, and negative 12, which is not good. So that one's not going to work. We'll just use 12. All right, let's turn the page. Log base 7 of 27 plus log base 7 of 3 equals 2 times log base 7 of x. Ooh, we got a lot going on here. We're going to use two properties in the same problem. First, we have log base 7 plus log base 7. We can put these two back together with multiplication. And 27 times 3 should equal 81. So we're going to put those two back together as one log of 81. Then we're going to do the reverse of our power property. And we're going to put that 2 back on top as a power. We had a multiplier in front of our log. We're going to reverse it and put it on top of x as a power. Log base 7 of x squared. And now we do have log equals log. Log base 7 equals log base 7. So this is like the problems that we did just a little bit ago, a couple days ago. Log base 7 of something equals log base 7 of something else. That's only possible if these two things are equal. So 81 has to equal x squared. Square root. Normally we'd write plus minus 9. I'm going to write them both out. X equals 9. X equals negative 9. Because I know one of them's I've done this problem 5 times a day. I know one of them's going to cancel out and the other one's not. So if you have plus minus, it's tough to cancel or cross one of them out. Okay? So to check our answers, we have to go back all the way up to the original problem and plug them in. If I plug 9 in, okay, it stays positive. This is not log equals log, so I'm not looking like it has to equal whatever, okay? If I plug this one in, it's going to be negative, and we're going to say no. Okay, to compare, like even on the next line down, negative 9 squared would have been positive 81, and it would have worked out. But you still have to go back to the original problem to double check your answers. Okay? Alright, I think this one's pretty doable for you. Go ahead and push pause and give it a shot. Notice that it is subtraction. Okay, ready, set, go. Alright, looking at that problem. We're putting them back together with division. We have 56 over n, log base 3 of 56 over n, equals log base 3 of 7. They're both log base 3, so I know these pieces have to be the same. Okay, n's on the bottom, so we're going to multiply both sides by n. And then I'm going to divide both sides by 7, and we get 8. Double check to make sure 8 doesn't cause any problems when I substitute it back into the original. It doesn't. We are good to go. Alright, I need you to mentally prepare yourself for probably the toughest problem and the longest problem on this note sheet. Okay? There's not one step here that's going to be mathematically crazy that you would not be able to do. It's just that there's a lot of writing and there's a lot of steps. Okay? So we have 3 to the 2x power equals 6 to the x plus 1 power. Previously, with a problem that looked like this, we would try to change the base to match up. So we could say that they're the common base, and then we could compare the exponents. It's not always possible to rewrite the bases as a common base. 3 and 6 look like they should be related to each other, but you can't do it. You can't rewrite 3 and 6 as a common base. So what do I do? How can I get those exponents down? Well, we have a new power property of logs. So I'm going to do the log to both sides of my equation, and that will let me bring my exponents down in front. Okay, and I'm going to kind of squish this over to the right a little bit so I'm not on this dark line here. 2x times log 3 equals parentheses x plus 1 times log 6. And we're going to use the common log. You could use any log you wanted to. You could use log base 5, log base 12, whatever. But if you do any of those other logs, you're going to have to write the little base number under it. So if you use common log, log base 10, it saves you from writing the little 10. If you really want to get efficient, you could have used natural log, and that's one less letter to write every time. Okay, the next step, we will distribute. We're going to take that log 6 to the 1 and to the x. So we have 2x log 3 on the left-hand side. On the right-hand side, we'll have x times log of 6 plus 1 times log of 6. Okay, we have an algebra problem. We have x's on the left and x's on the right. We want to get all of our x's on the same side and separated away from anything that doesn't have an x. Okay, so this side only has something with an x. This side has an x and a no x. So I'm going to move this one over. Now these are kind of like square roots in that you can't combine them unless they're exactly the same root. So we have 2x log 3 minus x log 6. Cannot subtract those. Don't do it. Okay, we're going to have 2x times log of 3 minus x times log of 6 equals 1 times log of 6 is just log of 6. Okay, why did we want everything with an x on the left-hand side? Okay, now we have everything with an x on the left-hand side, everything without an x on the right-hand side. So everything over here has an x. And if everything over here has an x, I can take that x out in front. We can factor an x out in front. And now we'll just have 2 times log of 3 and we already used that x, we took it out in front, minus log of 6 equals log 6. Now we have x times something equals whatever. X times something. How do I get rid of that something and only have x left on this side? X times. We're going to do the opposite of times. We're going to divide. And we're going to divide by that parentheses group. Divide both sides. And now that is going to cancel. And we'll just have x on the left. And we'll have just that on the right, which we can now type into the calculator. Okay? I would recommend using the fraction bar. Alpha y equals. First choice there, numerator over denominator. On the top, we'll have log of 6. Close your parentheses. Okay, log button again, down there by number 7. Divided by, bump down to the bottom, 2 times log 3, close the log parentheses, minus log 6. Close your log parentheses. Most of these log problems we're going to round to 4 decimals. So we're going to divide, or we're going to go 4.4190. If you don't have the fraction button, we can divide and just use a lot of parentheses. Log of 6 divided by parentheses for the denominator, 2 times log 3. Close that parenthesis. Minus log 6. Close the log parenthesis. Close your other parenthesis you opened for the denominator. 4.4190. There we go. See, that was a long problem, a lot of little steps. You had to write log about 10 times. Okay, but it wasn't anything too crazy. We used a log property to bring those down in front. We used distributive property. We got like terms on the same side. We factored out the common term, and we divided by a parentheses group. Okay? A little bit easier now with e and natural log. Okay, I see we got the e there. We know it's going to be solving with natural log, but first you have to peel back the layers and get the e by itself. So we start off by subtracting 2. Four times e to the x equals 30. And then we're going to come back and divide by 4. E to the x equals 30 over 4, reduces to 15 over 2. If you want to go decimal, it's 7.5. Now, to get rid of the e and get x, natural log and e are opposites. So I'm going to do natural log to both sides. 2 ways to think about it. Here's the mathy way. Natural log is really log base e. Log base e of e would be 1. Okay? And we'd have this x down in front with the power property and have x times 1 for just x. Or you can think about it as natural log of e, or natural log and e are opposites, they cancel out, and x falls down. Whichever way works better in your brain. 7.5. Okay. Natural log, 7.5. Remember, natural log ln, that's right by the other log. And we have 2.0149. Okay, last problem. Starts with natural log. Probably going to use e to cancel it out. Again, got to get rid of all the layers. You got to get down to just natural log first. So we start with plus 7. And then you can think about it the mathy way. Natural log is still a log, so the answer is an exponent. 3 is the power of base e that gives me this, so e to the third equals that. Or we can think about it as we exponentiate, bump both sides up into the exponent of e. E and natural log cancel out. X plus 2 equals e to the third. We're going to subtract 2. That's a big 2, not a little 2 in the exponent. E to the third power minus 2. Okay, e and natural log are related, so they share a button. It's going to be second natural log. To get to e, we had e to the third, and then arrow out to get back down to the ground, minus 2, enter. 18.0855. All right, folks, I know that was a long one. Thanks for your attention. Tomorrow is going to be a day 2, no notes, just a worksheet. Okay, good work today, and we'll see you next time.